On April 9th of 1943, the ENIAC began construction at Penn State University. It would use electricity so it could calculate and crunch numbers very quickly and easily. Its design would be improved to become more advanced and compact so that it could be incorporated into many of our devices today. The ENIAC was revolutionary because it helped change our way of communicating and entertainment. Eckert was a student at the Moore School, and during his school years, he invented a number of different machines. Like one of them was a machine called the oscillometer. A couple would grab handles wired to the oscillometer, and light bulbs would light up when the couples kissed, completing the electric circuit. When he was done with school, he heard that the Army wanted a better and faster radar to use, so by doing some research and replacing some materials with other ones, he made a faster and better radar. Because of this work, he developed skills with high-speed electronic circuits and mercury delay line tanks, which would be crucial to building the ENIAC. During World War II, when the U.S. was making bigger and more powerful guns, but to be able to aim these guns, tables had to be made to fire them. Groups of women would work for weeks calculating these tables by hand. Soon the heavy artillery guns would be finished before the tables could be made, so the Army would end up with useless weapons if they couldn't aim them. So they had to find a way to make these tables faster. I was just at the right place at the right time. It was divine providence or fate that selected me to be an ENIAC programmer. Betty Halberton quoted something interesting recently. Look like a girl, act like a lady, think like a man, and work like a dog. Jean Bardick. During World War II, as bigger artillery guns were being made and shipped to new grounds, teams of women were made to calculate the firing tables for each gun. Since the war moved all over the place, the terrain kept on changing. But since they could not calculate the tables fast enough for the new guns, the Army sent Lieutenant Goldstein to finding a way to calculate the artillery tables faster. He went to Penn State after he heard from a student about Eckert and Mauchly, two people who had an idea on a brand new calculating machine.
Are people becoming obsolete? A giant electronic brain has started cogitating at the University of Pennsylvania. It's made of vacuum tubes, like your radio, and it can add up a column of figures a yard long in a second. It's the world's first electronic computer. Right now, it's solving mathematical problems for the U.S. Army, but who knows? Someday a machine like this may check up on your income tax.
The ENIAC was built for war purposes by a group of engineers. The blueprints were provided by Eckert and Mauchly. The Army needed something to calculate artillery firing tables, so Eckert and Mauchly wanted the ENIAC to be built. Many computers before would use physical counters to calculate, so Eckert and Mauchly designed a system of using vacuum tubes to control electricity to do faster calculations. If Eckert and Mauchly didn't have the plans and brains to make the ENIAC, the computers we have today wouldn't exist. Even though the ENIAC was completed after the war, it was still used. It was used to perform calculations for the design of a hydrogen nuclear bomb, cosmic analysis, thermal ignition, and the wind tunnel design. The ENIAC was also the first computer to do a numerical weather.
UNIVAC is saving time and increasing efficiency for business, industry, and government. And of course, that is the business of Remington Rand.
UNIVAC, the giant electronic brain made only by Remington Rand, takes business statistics from magnetic tape, letters, numbers, and punctuation marks, processing them through its electronic circuits at phenomenal speeds. UNIVAC can compute payrolls electronically, then produce printed checks in a flash. Over 8,000 checks an hour with this high-speed printer. UNIVAC leads the field of electronic computing.
12,000 additional units of information. And all of this complex weather data is analyzed in the heart of the UNIVAC, the electronic central computer. capable of making over 2,000 mathematical calculations per second. Now, here is where we get the answers. You might call it the voice of UNIVAC. Actually, it's a high-speed printer that prints results at the rate of 600 lines a minute. So you can see that UNIVAC is both fast and versatile.
In 1947, after the new UNIVAC was unveiled, Mauchly and Eckert would go and disassemble the ENIAC because of the advancements of the UNIVAC. The ENIAC became the base for many of our computers today. It revolutionized the way we communicated and stored information. The vacuum tubes would be the beginning of the microchip, a key component in the ways our computers calculated and used data. The use of electricity instead of physical counters made it easier to make more compact designs. These would continue to be improved on even to this day to make where a calculator on the ENIAC is equipped with 18,000 vacuum tubes and weighs 30 tons. Computers in the future may have 1,000 vacuum tubes and perhaps weigh 1.5 tons. Presper Eckert.
The size and speed of computers have changed dramatically since the development of the first general-purpose electronic digital computer, the ENIAC. Built in 1946, the massive computer could perform about 5,000 additions and 1,000 multiplications per second. Early computers like ENIAC used bulky, unreliable vacuum tubes. The invention of the transistor in 1947 led to the production of faster, smaller, and more reliable electronic computers. Development of the integrated circuit in the early 1960s continued the miniaturization process. Many of today's integrated circuits contain millions of transistors and other tiny parts on a small chip. Smaller and less expensive components made the development of smaller computers, called personal computers, possible. Today's personal computers are more powerful than the room-sized computers of the past. They are able to carry out millions of instructions per second. Small portable notebook computers usually weigh less than 5 pounds. Even smaller computers can fit in the palm of the hand.
It's absolutely incredible. Nothing is believable. When you look inside a computer today, it's like I was in a different world. Herman Goldstein.